This is a sequences and series question. They've given us an arithmetic sequence, so an arithmetic or linear sequence is one that goes up by a common difference all the way through. And if we look at 2 to 8 and 8 to 14, we seem to be adding on 6. So this arithmetic sequence would mean we would continue to add 6 and keep going with that. So it's worth just appreciating that, okay, the next term is going to be 20, and after that it's going to be 26, and then it's going to be 32, and so on and so on. Now ask us straight away for the nth term of the sequence. There are a variety of different ways of doing this. You can use the formula that's given to you in the formula book, which is a plus n minus 1 lots of d. You could do it that way, where a is the first term and d is the common difference. So a is 2, and d is that common difference between two successive terms, so it's 6. So I could substitute in my 2 and my 6 into that formula, and when I've worked it through and open up to all the brackets, I would end up with 6n minus 4. That's one way of doing it. Another way of doing it is appreciating the structure of a linear sequence. A linear sequence is made up of basically a times table and a constant number. So if I think of the numbers 2 and 8 and 14 and 20, since it's going up by 6 each time, well, the times table sequence that goes up by 6 each time is the 6 times table. So if you just imagine what the 6 times table looks like, and we say to ourselves, well, each of those numbers, what would I do to each of those numbers there to make them the same as my actual sequence? Well, if I took away 4, I'd get 2. If I took away 4, I'd get 8. If I took away 4, I'd get 14. If I took away 4, I'd get 20. So we basically have the 6 times table, and we're taking away 4 from that. So I get my formula a slightly different way. Getting it from understanding what's actually happening in the sequence, as opposed to just like some robots just using a formula and substituting 2 numbers into it and rearranging it. It's good to have both methods available to you as a skill. Moving on to part B, we're asked to find how many terms sequence are less than 150. Well, if we think about this sequence, it carries on. I could carry on adding on 6. So, 38, 44, 50, 56. And I could keep doing that. And I could list them all out. And I could just then get to the point where one of them is below 150 and another one's above 150. And I just count up how many numbers I have up to, but not including that last number. So basically any number that's less than 150. Now there's absolutely nothing wrong with that as a process. I'm not going to do it here. I've told you what you can do, and you just count the number of numbers you've written out and write that down, and that's how many terms there will be. An alternative approach is to say to yourself, right, okay, I've got my formula 6n minus 4, so all we need to do is find out which term is just below 150, or indeed you might think of it as being just above 150. I'll go with the last one, the one that's just before 150. So if I take my 6n minus 4, which is any term, and I want it to be less than or equal to 150, so all I need to do is solve that as a linear equation. So add 4 to both sides, divide by 6, and I get 25 and 2/3. So the only number that can be just below 25 and 2/3 is the number 25. So 25 terms are all below 150. The 26th one will be almost certainly more than 150. Moving on to part C, we're asked to find the sum of the first 18 terms. So they're telling us 2 plus 8 plus 14, obviously that carries on, plus 20 plus 26 plus 32 plus 38 plus... And you could literally sit there and with your calculator just add up 2 plus 8 plus 14 plus 20 plus 26 plus 32 plus 38 and so on, and just carry on adding up 18 numbers and seeing what that answer is. And that's fine. Work that out, write down your answer, move on. Easy enough. The purist would expect you to use a formula. There is a formula in your formula books which is Sn is equal to n over 2 2a plus n minus 1 lots of d. Okay, so where n is the number of terms, here it's 18, and a is the first term, so that's 2, and d is 6 because you're adding on 6 each time, so your common difference. And if you were to work out that as a sum, you would get your answer to the sum of the first 18 terms, which is 954. And moving on to the last part, part D, find the value of n for when the sum of the first n terms is 420. So basically saying how many terms add up to make 420. That's basically what they're saying. Now we know that 18 terms add up to 954, whichever method you used. So it's going to be less than 18. So how many terms add up to make 420? Now again, a very obvious solution would be just sit there and go 2 plus 8 plus 14 plus 20 plus 26 plus 32 plus 38 plus, and just carry on adding up until you get to 420 and just count how many numbers you've added up. That's perfectly acceptable as a method. The other method is to use the formula that we have here above and just make it equal to 420, and the unknown is n. And if we slowly open those brackets, we get 3n squared minus n equaling 420. Now that's basically a quadratic, and we then have to go through the process of solving that quadratic equal to 0. And we get two solutions from that: minus 35 over 3, that can't be right because 1, it's not a whole number, and 2, it's not positive, and 12. So we accept 12 and we reject that other sort of fractional number. So the answer is 12. But to be honest with you, that's a whole heap of sort of process, and it would be far quicker just to sit there and go 2 plus 8 plus 14 plus 20 plus 26 and carry on adding up and seeing how many numbers you need to add up to get to 420, and you'd find there'd be 12 of them.